2, 3, go. Yo, what up, everybody? Today we're going to be talking about work. And you might see an equation like this saying work is equal to force times distance. But you might also see an equation like this saying that the net work is equal to the net force times distance. So, what is the difference? How do you know which one to use? We're going to be talking about that in this video, so stay tuned. All right. So, work equals force times distance. And another thing we know about work is that it equals a change in energy. So here to show us how this works is Mr. Puffin, and he's going to push this block of ice across the icy surface of this lake at 10 newtons of force. But as he does so, there's also 10 newtons of friction force. And so he just goes on for 4 meters. And you can see that because the force in front is equal to the front force in back, you have balance forces, so his speed stays the same. He doesn't speed up or slow down. And so if we want to see how much work he did, using the first equation, we just do 10 newtons times 4 meters, and 10 times 4 is 40. But let's do it with the second equation. He has not sped up or slowed down this block of ice, and so the ice's energy at the beginning is equal to the ice's energy at the end. All right, and so you don't have a change in energy, which means you don't have work. So how come we're getting 40 newton meters from this first method, but we're not getting any from the second? And the answer is the second equation is dealing with what we call net work. Right? And net work is how much positive work is done to something minus how much negative work. Because what's happening is there's also a force in the opposite direction. There's the force of friction. And that force of friction is pushing backwards with a force of 10 newtons. And that force acts also for 4 meters. But the force is opposite the direction of the motion, so we give it a negative sign when we find the work, right? So it's a negative 10 times 4. Again, negative because the force is opposite the direction of motion. All right, so negative 10 times 4 is negative 40. And so you see the net work is like how much positive work there is minus how much negative work there is. So that ends up being 40 minus 40, or 0. Okay, so now it makes sense that we're getting a 0 change in energy. All right, so another example, let's say he pushes harder this time. So there's more force in front than there is in the back. And as a result, this thing speeds up. So finding the work that he did by pushing on it, you have 15 newtons times 4 meters, which is 60. Right, but also there was a 10 Newton force of friction still, and that force was applied over those 4 meters in the opposite direction. So that would be negative 10 times 4, or negative 40. All right, so will the net work, all right, will it be 60, will it be negative 40, or is it going to be something else, okay? And so to help you understand this, just think of it this way. The block of ice had no energy in the beginning. Him pushing on it gave it 60 joules, right? That's what we found by doing force times distance here. At the same time, the surface of the ice is taking away energy from the ice, right? And that's found by doing force times distance as well on the friction force. That ended up being 40 joules, right? So there's 60 joules coming into the ice, 40 joules leaving. How much energy does the ice have now? And the answer would be 20 joules, right? Because 60 went in, 40 went out. So the net work is 60 minus 40, which is 20. That equals the change in energy. And so the ice changed its energy by 20 joules by going from being at rest to now moving at a certain speed. All right, we could have done this a different way. We could have first found the net force, right? So this is where this equation comes in. Net work equals the net force times distance. And we see that there is 15 newtons to the right, 10 newtons to the left. We subtract those, we get the net force, which is 5, because there's 5 more newtons of force pushing it forward than back. And that 5 newtons of net force was applied over a 4 meter distance. So we get 5 times 4 would be the net work. That would be 20 joules. All right. So to summarize, you would use the work equals force times distance if you're looking at the work done by one particular force. But if you wanted to see the work done by all the forces and the resulting change in energy of that work, then you would use this equation. The net work is equal to the net force times distance. All right, so hopefully that helped, and I'll see you all in another video.